Okay, so of course speech requires a number of different cranial nerves, as you probably already know from studying A&P last year. But the point of the understanding the neurology of speech is to realize that the cranial nerves themselves are innervating organs of the body through the sympathetic and parasympathetic systems, such as the lungs, the bronchi, and so on, that allow us to speak or produce utterances fluently. So again, re-emphasizing the point that speech as a human skill is something that is enormously complex, but requires the orchestration of a large number of different systems to be fluent. Therefore, even minimal damage to the brain or central nervous system can often result in slight language disorders. Even slip of the tongue, such as my own in this last lecture, because of environmental conditions that are not ideal. So speech requires respiration, phonation, resonance, articulation, prosody, and all of the nerves that we've reviewed, ranging from the trigeminal nerve 5 right up to the hypoglossal number 12, and spinal nerves too, C and T, cervical and thoracic, are necessary for fluent speech. But we haven't actually discussed the sensory tracts, and it's important to do that before we move on to system damage. And I want to just point out that not only is the system for speech a motoric system, but there is necessarily a sensory system attached to the speech mechanism. And these are multiple, but let's just look at three. So we've got the ability to be able to understand, perceive touch, vibration, and these two things are necessary for proprioception, particularly when it comes to voice. So the ability to modify our voice as high or low, or to use different tonal inflections, these are all things that depend upon the sensory feedback we get from proprioception that are part of the dorsal column, the tract called the dorsal column, which is in the spinal cord to begin, and then lands in the sensory cortex via the thalamus. So the sensory cortex here, don't forget we're starting down in the spinal area, and then we're moving up to the brain, and the spinal cord connects to the parietal lobe through the dorsal column, providing feedback which can adjust through proprioception the ability to modify our voice. Similarly, the spinothalamic and the spinocerebellar. So the same story occurs with the spinocerebellar, as I mentioned in previous lectures, particularly auditory signals, but also inner speech we think might be carried out here, so that this is proprioceptively fed back to the cortex to adjust the motor system to correct itself and produce more fluent speech. So this is the ascending sensory tracts, ascending because they're going up, whereas the motor system is going down from the cortex to the spinal cord. And so if you remember also when we talked about the reticular activating system, we talked about ascending and descending. We have two separate systems, often coincident in where they are located. So the two are often side by side, but the functions of these are quite different, and that's necessary for normal speech.